Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning. Today I want to talk about coastal wetlands and their role in climate feedbacks and carbon sequestration. We will look at the ecological processes that allow these habitats to store carbon, the risks they face from sea level rise and warming, and a few real-world management responses. Coastal wetlands include salt marshes, mangroves, and seagrass meadows. These systems sequester carbon in both living biomass and in sediments. The key technical term is blue carbon. Blue carbon refers to carbon captured by coastal ecosystems and stored in sediments over long time periods. One reason wetlands are efficient carbon sinks is their anoxic sediments. Low oxygen slows microbial decomposition, so organic matter accumulates. That leads to deep peat or organic-rich mud that can lock away carbon for centuries. For example, mangrove soils can store 2 to 4 times more carbon per unit area than terrestrial forests. However, these systems are not static. Sea level rise, subsidence, and changes in sediment supply can change whether a marsh builds up vertically or drowns. If sediment deposition and plant root growth keep pace with sea level rise, the marsh may persist. If they do not, the marsh becomes submerged, oxygen penetrates deeper, and stored carbon can be oxidized and released as carbon dioxide or methane. I want to highlight 2 feedback processes. A positive feedback occurs when warming or sea level rise makes wetlands less effective at storing carbon, which in turn increases greenhouse gases and accelerates warming. A negative feedback would be increased plant productivity as CO2 rises, leading to greater carbon uptake, but that effect can be limited by nutrient availability or salinity stress. We have good measurement tools for these dynamics. Field flux towers that use the eddy covariance technique measure exchanges of carbon dioxide between the ecosystem and the atmosphere. Remote sensing from satellites gives us broader scale information on surface elevation change and vegetation extent. Combining these methods allows researchers to estimate net ecosystem carbon balance. Let me give a case study. The Mississippi Delta experiences subsidence and reduced sediment delivery because of river channeling and damming. Restoration projects there attempt sediment diversions to rebuild marsh platform and preserve habitat. These actions can restore carbon burial potential, but they are costly and politically difficult to implement. Another striking example is mangrove restoration in Southeast Asia. When mangrove areas are cleared for aquaculture, stored soil carbon is often released rapidly. Restoring mangroves has shown measurable gains in carbon sequestration over decades, and it also provides co-benefits like storm protection and fisheries habitat. Policy instruments are beginning to include blue carbon. Market mechanisms such as carbon credits for restoration projects can provide funding. But markets must be combined with regulation and community engagement. If projects are not monitored with robust methods like flux towers and sediment cores, claimed carbon benefits may be overstated. We should also consider methane production. In some waterlogged systems, anaerobic conditions favor methane-generating microbes. Methane has a stronger short-term warming potential than carbon dioxide. So, a wetland that reduces CO, the second of, may still increase near-term warming if methane emissions are substantial. Assessments, therefore, need to consider both gases. Finally, I want to emphasize an important point about strategy. If we only focus on carbon pricing without investing in restoration, we risk losing the natural capacity of wetlands to sequester carbon. That is why integrated approaches that combine mitigation, adaptation, and conservation are necessary. In summary, coastal wetlands are high-value carbon sinks with important climate feedbacks. Their fate depends on physical processes like sediment supply and on human decisions about restoration and land use. Accurate measurement and careful policy design can help preserve their climate benefits while supporting local communities.
Listen again to part of the lecture, then answer the question.
If we only focus on carbon pricing without investing in restoration, we risk losing the natural capacity of wetlands to sequester carbon.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.